So for our agenda, I'm going to start off talking to you, as I mentioned, about Washington's volcanic hazards, and then I'm going to talk about earthquake hazards. I will pass this over to my colleague to talk about Washington's tsunami hazards, followed by some wildfire hazards, something we've all been experiencing a little bit of smoke lately, or fire in some cases, and then talk about just general preparedness in Washington and where we have some resources available for that. And finally, after that, we'll get to answering some of your questions that haven't been answered already. So please continue to put those in the chat and the Q&A session as you have those, and we will get to them when we can. So jumping right in, we're going to talk about volcanoes. Volcanoes in Washington are one of my favorite subjects to talk about, so I will try to keep this as brief as possible, but as information dense. So I'd like to start off with this mountain here. Does anyone recognize this? It looks really familiar if you think about it. It's got that nice cone shape, really beautiful lake in front of it. This was a part of a lot of people's childhoods in Washington, but they would come there for the summer. However, this mountain drastically changed on May 18th, 1980. And that drastic change also had the effect of drastically changing the way that we look at volcanoes and volcanic hazard in Washington. A really dramatic eruption of Mount St. Helens, or Lewitt. So if we look at the Cascade range in the past 4,000 years, this is a graphic from the United States Geological Survey, the Cascades Volcano Observatory. I will be mentioning them a lot during this because they are the expert agency on monitoring all of our volcanoes in the Cascades. Now I have up to Mount Hood circled here, but the thing I want to focus on is we have 5 active volcanoes in Washington. And as you can see from this graphic, all of these have had eruptions within the past 4,000 years. Now that's what we consider an active volcano here in Washington. Might not be erupting right now, but they're kind of in a state of just add magma. You just add a little bit of magma into there and they could start erupting again. And as you can see, one thing I want you to take away from this graphic is Mount St. Helens has been our most active volcano. And if you had to bet on it, let's say it's most likely to erupt again. We can't predict to erupt again next. Can't predict exactly when it will happen, but erupt in 1980, again from 2004 to 2008. Get a lot of activity from this mountain. Another thing to take away, all of our other volcanoes have this activity as well. So 4 of these, Mount Baker, Glacier Peak, Mount Rainier, Mount St. Helens, are all within the very high threat category that the USGS established. Now that's based on their frequency of eruption, which you can tell is here. And that's also based on the fact that they could impact people if they erupt. We'll talk about what those impacts are. And also just based on the fact that they have hazards that could impact a lot of people, from lava flows to ash explosions to lahars are the really big one, these volcanic mud flows. So we have 5 active volcanoes in this state. And each one of them deserves recognition for being a potential hazard. One thing about volcanic eruptions, when we look at those, is they're really unique among all the other things we look at. Have this graphic over here to kind of compare floods and hurricanes, earthquakes and tsunamis, wildfires, eruptions, to kind of just show how much warning you get before them versus how long that they last. When you see floods and hurricanes, we typically have a couple days, maybe even a week of warning. We know roughly where they're going to go, where they might strike, that kind of warning before they happen. And that event will last days or weeks. This is not counting recovery, of course, it's just going to take a much longer time to get everybody back after that. When we look at earthquakes and tsunamis, they're going to start with either that ground shaking or a spark. You don't really get much warning before those events happen, but they can last a long time, weeks to months potentially, if you consider the aftershocks, or a couple of days for tsunamis you'll hear about later. Okay, I'll talk about it soon. You can actually get a couple seconds of warning before an earthquake in Washington now. But that's really not much, not enough to show up on this time scale. When we look at volcanic eruptions, though, the volcano can show signs of unrest for weeks, months, potentially even years before it actually does anything that we consider an eruption. That event of an eruption itself, too, can last days. It could just be one explosion, but it could be days, weeks, months, years, and the impacts to it can last that long as well. So I'd like to bring that back to this one really quick again. Each of these little volcanoes here just represents a period of eruption. It represents a time that the volcano spent erupting. It's not just necessarily one explosion. 1980 was more than just the May 18th eruption. That volcano had activity for a while. That next one that's most recent here, that represents the whole period from 2004 to 2008. So it's sometimes hard to tell just by looking at rocks exactly how long an eruption lasted, but we know that these have all happened in the past. So hopefully that clears it up. What this means for us in the emergency management field, sometimes you have to make decisions before the outcome of the eruption is known. So we have this graph kind of showing on the left here, if you're looking at the volcano's heartbeat and blood pressure, one way to think of it, you go in for these checkups, checking the seismometers on the volcano, whether it's making any movements in the ground. You're checking the GPS stations to see if it's rising, if it's inflating at all. As those increase over time, you know that the volcano can do several different things, but people have to make a decision about what to do. Should we evacuate certain areas? Should we recommend that people leave them? Should we lower water in dams to mitigate Lahar hazards, things like that? And over time, there's no real time scale on this because it depends on the volcano. The volcano could do something completely different. Like, for example, in 2004, Mount St. Helens started showing signs and really quickly progressed into an eruption. It started building that lava dome only a couple days after its seismic activity increased. Whereas back in 1980, it showed those signs, and then there was about a month and a half of activity before it had its large eruption that happened. Have this other example here, back in 1975 from Washington, Mount Baker. It started showing all this heat, excess heat at the volcano, and people started doing things, closing campgrounds around it, lowering the water in Baker Lake Dam just to make sure that they were ready in case the volcano erupted. And it's been about 6 months not doing anything, and it never erupted with that period. All of these things are possibilities, and it makes it really difficult to make decisions. So what I want you to understand is that when a volcano is showing these signs of unrest, it's kind of getting ready to get out of bed potentially. There's a lot of things it could do, but there's a lot of uncertainty. It could get up really quick. It could hit the snooze alarm and go this way, or it could just immediately go back to sleep, or there's plenty of options here. So uncertainty with volcanic eruption, but the folks at the observatory, your local emergency managers, are going to be doing everything they can to give you the best information to forecast what might happen so you can make decisions. Okay. So on that topic of volcano monitoring, how can we actually tell when a volcano will wake up, when it'll get out of bed, or even just what it's doing? I like to think of this again as that checkup metaphor. You're supposed to go into the doctor once a year, twice a year, just to get that long period understanding of what your heartbeat, what your blood pressure, what your just kind of what your vital signs are over time. Now, the way they do this with volcanoes is get a long-term record of what the volcano does seismically, how it deforms. Does it breathe? Does it expand and contract normally? What kind of gases are normally coming out of it? What kind of chemistry is in the streams? What are their temperatures? And you can even get visual. Sometimes you can even see a volcano deforming. I mean, a couple of weeks ago, we actually had a time where people thought that there was venting coming from Mount Rainier. Now that turned out to just be a cloud, but that kind of observation is actually really helpful. We just recommend that rather than really quickly tweeting about it, you actually contact the observatory so they can confirm it. Because they're the ones who are going to be able to tell if there's other signals associated with it. If a volcano were venting, there would very likely be a seismic signal to go along with that, something shaking in the ground that would be able to detect, because that kind of gas release actually has other signals associated with it. So the observatory scientists watch our volcanoes very closely. They have been for years. They have records of it. And that's how they know when something changes. For example, you get all these kind of seasonal swarms of earthquakes at Mount Rainier, but we know that that's normal, especially as the amount of ice on the volcano changes. It tends to get more earthquakes. But they look at these and they know that this is a normal occurrence. They know what's normal for that volcano. And when you know what's normal for a volcano, you can tell when something is abnormal, something is different going on. You can tell the same for this deformation, gas, stream chemistry, temperature, and just watching it. So this is a really important part of monitoring, making sure there is a long history of the volcano and what it does. And all the instruments are out there to do that. Basically, what these are there for is if magma enters the volcano, remember they're all active, you just have to add magma for them to start erupting. They will change things. Magma has to break rock to move through, so it's going to cause seismic signals. It's going to change the rock, so it might inflate it a little. GPS and tilt meters can detect that. It might cause new gases to enter the stream, to enter the vents. So there are all sorts of signals that can be detected when a volcano may be moving towards eruption. So the other part of this, we need to know what a volcano might do when it erupts. Now, each of our volcanoes, in addition to normal activity, kind of have their own personality when it comes to eruptions. And the geologists, both the USGS Cascades Volcano Observatory and our Washington Geological Survey especially, they go out and study outcrops. They go out and find maps, or they go out and find deposits from what the volcano has done in the past, or the past 10,000 years. And based on that, they can establish a characteristic type of eruption from each volcano. And if you look at what a volcano has done in the past, you can understand what it might do in the future. So looking at those, we can figure out which of our volcanoes are more explosive. That's Mount St. Helens and Glacier Peak, versus which ones are more likely to have just kind of less large lava flows that come out. Our lava is a little different than Hawaii. It's very viscous, kind of more like toothpaste, whereas Hawaii is more like water. It flows very slowly. But the problem with that is it can melt a lot of snow. So we'll talk about our Lahar Hazard in a little while. But for example, this is looking down the this is a deposit from Mount Rainier that happened about 5,600 years ago during its Osceola mud flow. 31 miles downstream from Mount Rainier, this is a deposit 26 feet thick. So this is how we know what kinds of things might happen when an eruption occurs, and what kind of hazards there are that we need to worry about. Where you can find this information, volcano hazard maps. We have these for each of our volcanoes in Washington. So what these show is we have the area of the mountain. This is where near volcano hazards occur. And for our volcanoes, this is mostly within federal land, within national parks, within national forests. This is where you get really unpredictable hazards. This is the area that is really unsafe to go into if a volcano is experiencing unrest, because it's really hard to predict which way ballistics will fly, which direction a lava flow or a pyroclastic density current or pyroclastic flow will come down, or where a hydrothermal explosion will happen. The important one we want to show on here is Lahar Hazard. These are these warm colors coming off the rivers off of the mountain. If you live in one of these zones that is warm colors, you live in a Lahar Hazard zone. And this is a volcanic mud flow, picks up all the debris coming down off the mountain over time. And it's just a fast moving flow of mud that can potentially bury things. Again, looking back at that deposit, that is what's left behind after one of these Lahar flows through. So you want to make sure that you are going to be alerted if one of these is coming, if you live in or work or spend time in these areas, because the only safe thing you can possibly do when one of these is coming is not be there. We'll talk about go bags later. This is an area where you want to grab your go bag and evacuate to high ground as quickly as possible, because you do not want to be in that place. It's not safe. So check out your local volcanoes hazard maps, find out if you live in one of these Lahar zones, or if you're going to spend time in one of these zones, make sure you know how you're going to get alerted if the volcano goes into a period of unrest. So one hazard that's not on the map, volcanic ash. Probably most people that were here during 1980 remember what this is like, because a whole lot of it came out of Mount St. Helens. Now, this is not the same as smoke ash. It's tiny little pieces of lava fractured by the explosion, little pieces of glass, basically. So small amounts can be a nuisance. They're not really fun to breathe in for long periods of time, can be very irritating if you have asthma or other conditions. Large amounts can be dangerous. Up to 4 inches if you get it wet is enough to collapse roofs. So you don't want to be around for heavy volcanic ashfall. Again, the heaviest is mostly going to be stuck within this pink area on the map. It's going to be very close to the volcano. But any way the wind blows, you can be downwind of volcanic ash. You know, ours in 1980 reached into Montana, for example. So yeah, you don't want to drive in this. It gets really easily resuspended. If you try to wipe it off with your windshield wipers, because it's little pieces of glass, it can actually scratch them. It can be really irritating to engines, do a lot of damage that way. Planes flying through it, bad idea. And it can stick around. It's really hard to clean up. Again, St. Helens and Glacier Peak are biggest ash producers, but all volcanic eruptions here might have explosions that could produce ash in different amounts. Going to look at that pink area again, the near volcano hazards. Some things you want to worry about here. Tephra, that really heavy ashfall. Ballistics, basically just anything that flies out of the volcano from the source of, or from the force of the explosion. Lava flows, again, here they're mostly thick, blocky, slow moving. but they can break off the front and you get these rock falls of really large rocks. Now, a fun thing I like to show from ballistics that happened is sometimes you get interesting headlines about that. Like in Hawaii back in 2018, they're warning about fridge-sized blocks of lava that might be coming out of here, ballistics, but somebody messed up on the headline and ended up saying it may spew fridge-sized refrigerators. Just know it's probably not actually throwing refrigerators, but there's no way to really predict which direction these are going to fly in. So if an area around the volcano is closed, that's for your safety. You don't want to gamble with refrigerator-sized or even smaller blocks flying out of a volcano at you. A big one here that's also unpredictable, you don't really know which way it's going to come out of, pyroclastic density currents or pyroclastic flows. Think of these as hot avalanches of gas, rocks, and ash. They can move very quickly. They don't necessarily remain in valleys as well. These are kind of what you see in volcano disaster movies, but they really happen as well. We saw them in Mount St. Helens, 1980. When these flow over the snow on our volcanoes, they can also start lahars. They can melt a lot of snow and ice and add ash to that. These are possible at all Washington volcanoes, but again, very near volcano hazard. If that area is closed, you can stay out of it. You will avoid being in the danger zone for these particular hazards. Now, if we look at ones that are very far downstream, I want to talk about lahars because this is probably our most important volcanic hazard, the one that potentially will impact the most people because these can travel tens of miles downstream. Again, we had that deposit 31 miles downstream. It's still 26 feet of mud from Mount Rainier. Mount Rainier is the most glaciated mountain in Washington, and it has more snow and ice on it than all the other mountains combined. That's a lot to melt. That can be a lot of water coming down our streams. So it's really important if you live in those areas to understand how you can get out of the way, how you can get alerted. So how these work, lahar is an Indonesian word for basically a mud flow that happens on a volcano. When it's, so theirs typically start in monsoon season when the sides of their volcanoes are covered in mud. A lot of rain falls on the mud and it starts to mobilize it, so it moves down the stream. If you think water is already really heavy, if you've ever been knocked over by a wave, now add that water being completely saturated by mud, and this can take out just about anything in its path. The one from Mount St. Helens in 1980 took out 27 bridges as it traveled down the North Fork Toutle River and into the Columbia. So these are a huge hazard, and again, you just have to get out of the way if these are coming. You have to understand that the things you leave behind might not be there when you get back. But if you take your go bag, you can survive this. You can get out of the way. We'll talk about go bags again as well and how to get alerted for things like this. This is a really important hazard to be prepared for in Washington, and understand that leaving behind a huge pile of mud, the things might even be buried that are there. I mean, some of our cities that are in these lahar zones are built on top of old lahar deposits. Yeah, so these can travel miles downstream from the vent. It's really important to know when one is coming, kind of similar to a flash flood, but leaves a lot more behind. So here's some examples of that from 1980. You can see that this just took out a bridge. We have a boulder here for scale, the small hammer just showing how big the boulder is that was floating on top of this mud flow. These are extremely destructive. We have a hazard map again. Remember, these rivers coming off the volcano are where these typically flow. It's where they might happen again. So if you're in one of these areas, it's just really important to understand that you are in that area and how you're going to get alerted and how you're going to get out if you need to. These lahars most often happen during eruptions, but there is a tiny chance that could happen outside of an eruption. And there's an area of Mount Rainier that could occur during a landslide. It's the least likely scenario, but just because it's there, Mount Rainier has a lahar warning system in the Puyallup River Valley, specifically for that. It will warn about other lahars as well. But yeah, just understand that if those sirens go off, you really need to get to high ground. Okay, so quickly jumping to volcano safety here. Volcanoes, like some weather events and like you're going to hear about tsunamis, have alert levels. Currently, all of our volcanoes are normal. They're in their background state. Again, that might mean that there's earthquakes occurring on them at certain times, but they're not unusual earthquakes for that volcano. They all have their own personality. They're all behaving in the way they have for years. If something happens at the volcano, it's possible the first thing that comes out will be an information statement from the USGS. If these alerts are all come directly from the USGS, they're the one who issues them. So if something happens, they might issue an information statement that says, hey, we noticed something happened at the volcano. We're watching it. It doesn't necessarily mean it's leading towards an eruption. Saw that about the Sisters volcano in Oregon. They noticed that over time, there was uplift of less than an inch over a 12-mile area. I like to just share that as an example of how closely they are watching their volcanoes, and they will let you know when something's happening. For instance, as well, the cloud at Mount Rainier last year did not even merit an information statement coming out. They didn't even need to share that because we saw something, but it was a cloud. If they see something that looks like it's potentially leading towards an eruption, they may change the alert level on the volcano to an advisory, which basically just means it's above background. And they're going to start watching very closely, dropping more monitoring equipment on these volcanoes. Know if it's moving even more towards the volcano, maybe get a lot more earthquakes, or you can tell that the earthquakes are moving up in the volcano, potentially going towards an eruption. It might go to a watch. It will go to a warning if they've decided that an eruption is imminent, underway, or suspected. Basically, if it looks like it's ready to blow, it might be in a warning. Now, what actually happens when these change? These are just going to be times for you to have increased awareness of your local volcano if anything's going on. We can't tell you to evacuate. Your local agency might be able to, but we do not have that authority. But if you live in a Lahar zone and you see that your volcano is at a watch level, just understand that that's a really good time to make sure you are very aware of exactly how you're going to be alerted about things. And there's always that potential to maybe go live with a friend for a little while. Know where your go bag is, especially. But the most important thing is you can get alerts for these. All our volcanoes are currently normal, but you can sign up to get alerted as soon as one of them changes. So be aware of alerts and warnings coming from that Cascades Volcano Observatory. They actually have a volcano notification service you can subscribe to. And then I'd just like to add again, if a place around a volcano is closed, it is for your safety, not trying to keep you away from things, trying to keep you safe. So follow the guidance of volcano monitoring agencies. They are the ones who actually know what's going on in a volcano. They've been watching it for years. They have that record. Follow the officials for information. And then know your area. Do you travel through? Do you commute? Do your children go to school in a volcano hazard zone? Talk with them. Make sure that you understand what that means. And in the meantime, Washington's volcanoes are absolutely beautiful, and they're a really unique environment, a great place to learn about the earth, about the history, about the culture around them, from the people that have lived around them for years. Each of them has their own name. They're really important culturally. So please take some time to enjoy them as well, because you can learn a lot while they're not currently erupting. Or maybe go visit a different one while your local one is erupting. What is our next eruption? We don't know. Again, if I was betting, I would say Mount St. Helens, but monitoring is really important to figuring out what's going to happen next. Meanwhile, please go enjoy our beautiful volcanoes. If you have questions about the volcano section, please put them in the chat and we will get to them later. And I will try to move through this next section a little quicker just to make sure we have time for everything. All right. So the next thing that makes Washington a very exciting place to live is that we have earthquake hazards. All right, so moving on to that. I have a map up here that shows why we have earthquake hazards in this state. Now, an interesting fact, Washington has the second highest earthquake risk in the United States. We are right behind California. And you might have noticed if you're watching, Alaska gets a lot more earthquakes than us. But when we talk about risk, what we're talking about is how many people are exposed to that hazard. So we know we have a subduction zone offshore that we could potentially have a magnitude 9.0 or higher earthquake and tsunami. That's happened in the past. We know that we have deep earthquakes, and we know that we have a potential for crustal earthquakes. Just because we haven't had them in a while doesn't mean we should not be prepared for them, that there isn't a really big risk for them. So I'm going to talk a little bit about why we have earthquakes here and what you can do to be more prepared for them and some of the systems we have in place. So hopefully this will help get you ready for those. So we have subduction zone earthquakes, our magnitude 9.0, the big one, or the really big one that could potentially cause tsunamis. My colleague will talk about shortly. So why what is this? Why does this happen? So our Earth is composed of tectonic plates. Basically, the surface is broken up into little pieces. Typically, the ones that are in the ocean, are made up of a denser rock. So they float. They're very thin. Our continents are made up of a thicker, but also less dense rock. So that kind of floats on top of the mantle a little better. Now out here we have the Pacific Plate, which is most of the Pacific Ocean, and that's diverging from the Juan de Fuca Plate, which is a much smaller one that's kind of will eventually, over the next thousands of years, completely disappear. But that plate is running into the North American plate that we all live on top of. So we're sitting over here on the North American plate, Juan de Fuca Plate. When it crashes into our plate, it subducts, it moves underneath. And the whole area that it moves underneath is called a subduction zone, and it extends from northern Vancouver Island in British Columbia all the way down to northern California. We left California off the map, and Oregon. That was kind of rude, but it is extended all the way down to there, about 700 miles long. So that whole area has been moving under there very slowly, about the speed your fingernails grow is how long that, or how quickly that moves. But as it gets stuck under there, just the force of friction of it moving together causes it to stick. But the pressure keeps building up even while it's sticking. Now, when that pressure is released, that is an earthquake. And when that releases along 700 miles of fault at once, that is a very, very large earthquake. Most earthquakes that we have, some of our larger ones, are typically about 30 to 50 kilometers or 30 to 50 miles for a let's say like a magnitude 7 earthquake. So this is much, much, much bigger. This is the biggest kind of earthquake we can get, are in these zones of subduction. So that is the really big one. That's why we can have it. Our last one was in the year 1700. Now, we know that thanks to a bunch of different things. One, the people that have lived here for a long time, our tribes on the coast, have stories about what happened. Now we can mix those with the fact that we have ghost forests on the coast. When that subduction zone earthquake strikes, the coast has been rising and it suddenly slips. It actually subsides. The coast drops down 6-7 feet or so. And we actually have forests that have a record of that because all the trees died when they were suddenly under salt water. So you can see these ghost forests, which sounds like an awesome Halloween costume. I'm not just going to throw that out there. Also, when that happened, there was an Orphan Tsunami that occurred in Japan. And that's how we know the exact date of when this occurred, because that wave from the subduction zone earthquake traveled all the way across the Pacific Ocean. And people in Japan at the time were surprised by a tsunami striking, and they have a record of that in the history. So we know that this occurred on January 26th, 1700, 322 years ago from now. Looking at records offshore, we can see that these happen every 200 to 600 years. So we are certainly within a window where this could happen again. If you ask the geologists about this who have studied that time interval, they'd say that we have about 15 to 25% chance that this earthquake will happen in the next 50 years. Could happen this afternoon, next week, next year. It might not happen in our lifetimes. It's really difficult to set a firm probability on this, but we know that if it would happen, it would have very big impacts on the region. So that is why we think it's so important to prepare for this. That's why we do exercises like Cascadia Rising to help understand what we would need to do to respond to an earthquake this large. It would be a huge event, the earthquake followed by the tsunami. So that's the really big one. Now, if we go further down here in the Juan de Fuca Plate, as that plate subducts, there are a whole bunch of minerals that make up that rock, and a lot of them contain water. As it heats up, as it goes a little deeper in the mantle here, it releases some of that water, which helps make the plate itself really brittle. And it starts to bend a little bit, and occasionally when it's bending, it snaps. Any Legally Blonde fans out there? That's what these earthquakes are. Deep earthquakes. In 1949, we had one of these. In 1965, we had one. And then some of you might remember as well, 2001, the Nisqually Earthquake. That's what type of earthquake this is. This is probably our most likely type of damaging earthquake that we can experience in Washington. Deep Juan de Fuca Plate earthquakes. They happen about 30 to 50 miles down on the coast, and they happen underneath us. So they can affect a wide area, but the shaking is generally less intense than shaking that happens from earthquakes right underneath us. So those typically happen every 30 to 50 years. Our last one was in 2001. And we say that there's roughly about an 84% chance that one of these will happen in the next 50 years, of a size large enough to be damaging. We do have a lot of smaller earthquakes. Finally, because we are shoved in between this subducting Juan de Fuca plate and the North American plate, we get a lot of pressure in Washington. Anybody feel stressed? Oh, that's not really what this is related to, probably, but the crust certainly is. And because of that, we can get all these crustal fault earthquakes. If you've heard of the Seattle Fault, the Tacoma Fault, the South Whidbey Island Fault, the Devil's Mountain Fault, the Lake Creek Fault, these are all over the state. The Chelan Fault, that's where we had our 1872 earthquake. So basically these happen because the crust itself near the surface is under a lot of pressure, and occasionally slips happen across these faults as well. These are a lot harder to tell exactly what the recurrence is. Again, we know that we had one in 900. We know we had one in 1872. And it can kind of happen all over the state as well. So roughly 15% chance one of these of a damaging size will happen in the next 50 years as well. So these are all active crustal faults. The big thing about these is if one of these earthquakes occur, I'll show some examples shortly, but they are right underneath you. So the shaking from these earthquakes is much more intense than, say, our deep fault earthquakes like in Nisqually. The shaking originated 30 miles away. A 6.8 is not a small earthquake by any stretch of the imagination, but when it happens 30 miles away, it's going to shake a little bit less strongly than something that happens right underneath you. So yeah, you can look at this map of where significant earthquakes in Washington have happened since 1872. You can see a lot of them happen in this Puget Sound region, but we definitely have them in other areas of the state as well. Again, that 1872 Chelan earthquake, looking at records of that people told stories about this when they were out there, people running out of their cabins, just kind of hearing what the damage was, can understand that this was an earthquake from about magnitude 7 to 7.5, and it was very intense because it happened on a fault that's close to the surface. That was our largest earthquake we've recorded in Washington, or most potentially damaging. You can see 2001, our Nisqually earthquake here, 1949. I think that's the Tacoma Narrows earthquake. And 65 as well happened in this area. So most of those are deep earthquakes, but also 1999, the Satsop earthquake caused a lot of damage. So, and then we had a small swarm of earthquakes back in 2001 in Spokane as well. So these can happen all over the state. And this is just since 1872. Earthquakes have a bit longer time scale than we're used to. Again, we had our 1700 off the coast. But just an understanding that Washington is earthquake country, and you can experience an earthquake wherever you are. And that's why hopefully being here today will help you to be more ready when that happens, how to react. So what to expect when an earthquake happens? They strike very suddenly, sometimes with a roaring sound. You hear a lot of people hearing earthquakes. Basically the sound, or the earthquake, the ground shakes at a variety of different frequencies. Some of them you might be able to hear. Some of them might resonate with something like glass or a light or something metal around you, so you might hear things. Everything will begin to shake, and the most important part of that shaking is it's unpredictable. It's really just the ground accelerating back and forth, up and down, with really strong forces in multiple directions. So if you've ever tried to walk on, say, like a carnival game or something where the ground shifts back and forth, that might be like predictable ground shifting. Picture this as just kind of all over the place in all directions all at once. That's what you might experience in an earthquake. Part of the reason we recommend not trying to move during one, a lot of people get injured by that because you cannot predict which direction it'll go in. You might see lights flickering, sprinklers, fire alarms going off, windows can shatter and break, things falling off shelves. There's all sorts of damage, and I'm sure you have different stories if you were here for the Nisqually earthquake and what happened, or experienced a different earthquake somewhere else. People might be screaming. It's scary when this happens, especially a large earthquake, because I mean, if you think about it, we kind of rely on the ground being solid beneath us every day. We expect that. When that suddenly changes, that is really scary. It is okay to be scared when an earthquake happens. It's really unnatural. What we want you to understand is just there are things you can do to protect yourself and minimize the damage you might experience when one occurs, which knowing what to expect should help with that. A really important thing we want to get across, as I mentioned before, do not try to run. They've done a lot of studies recently of earthquakes in California, in there's not as much data for ones in Washington, but a lot of the injuries people have received have been, and this is looking through hospital records, people falling when they are moving during the shaking or being struck by falling objects. This is why we emphasize drop, cover, and hold on. Drop, cover, and hold on means something different in every situation, but if you are up and running, you are in the position where you are most likely to be injured by things. You want to make sure that you are low to the ground, so you can't be knocked over by that unpredictable shifting. You're covering your head and neck under something sturdy, taking cover if possible, and you're holding on to that as long as the shaking lasts. These are how to avoid some of the biggest dangers during an earthquake. I will go back to that in more detail shortly, but I'm just going to talk a little bit about how we measure the earthquakes. I mentioned magnitude and intensity a couple times. So here's a little graphic. If you look at this little dot here, magnitude 6, we're just going to simulate that, and the area of these circles represents the relative energy of each of these. So if we talk about an earthquake's magnitude, each earthquake only has one magnitude, and that represents the total energy release. We can use a light bulb metaphor for this. Think of this as the wattage for a light bulb. A 40-watt light bulb versus if you jumped up to a magnitude 7, you get about 32 times more energy. So that would be I'm not going to do that math right now. Think of a higher wattage light bulb, maybe a 400 watt. Now, if you jump up another one whole element of magnitude, magnitude 8, for example, that would be an increase of 32 times 32, so 1024 times the energy of a magnitude 6. If we went up to a 9, I didn't even calculate that out, but you'd have the 1024 times 32, so significantly more energy as you increase in magnitude. Again, said that magnitude 7 earthquake happens. A lot of our faults that could produce that are only about 30 to 50 miles long, whereas the Cascadia at magnitude 9 is a 700-mile long fault. So significant amount more fault rupture, significant amount more energy release as you go to larger magnitudes. Now, if we talk about earthquake intensity, this is another way to measure it. Now, if we're talking about an earthquake only having one magnitude, it has a lot of different intensities. Now, intensity is what you feel where you are. So if we think about that light bulb again, if this light bulb has one wattage, one energy release from the whole earthquake, if I'm right here next to this light bulb, I'm going to feel that light a lot more intensely. I might even feel heat from it. It's going to be lighter than if I was over in the corner of the room, or maybe there was a screen between me and the light. The light I receive is going to be different. I'm going to get a different intensity of light. Hopefully that metaphor works for it. But based on that, we can do a modified Mercalli intensity scale, which is what the United States Geological Survey uses to produce maps of what shaking actually occurs in certain areas after an earthquake. And you can contribute to this. If you've ever filled out a "Did you feel it?" survey after an earthquake, you have contributed to these because you've described what you've actually felt, what has actually happened in buildings around you. All of these actually correlate to levels of ground shaking, the speed at which the ground was accelerating, or peak ground acceleration as they call it as well. So it's kind of a qualitative, what you experienced, mixed with quantitative, how much the ground actually accelerated to come up with these numbers. But basically, one earthquake has one magnitude, many intensities, depending on where you are, what you're standing on, what kind of building you're in, what the ground underneath you is like. So you can see this from shake maps that they make. So an earthquake here, I believe this is an example. This is a shake map for the Cascadia subduction zone scenario. Magnitude 9 earthquake, only one magnitude. But you can see each of these areas has different intensities of shaking. So what we want you to take away from this is understand what the intensity might be where you are from a variety of different shaking scenarios. This can help you kind of get an idea of what kind of shaking you might want to prepare for. For Cascadia subduction zone, our coasts might experience a lot more intense shaking versus, say, if we had a Seattle fault scenario, that would have very intense shaking right along that area, but less intense as you go further away. And you can again find the modified Mercalli intensity scale to find out what these different levels mean, what kind of structures might be damaged. If you find that you're in an area that might experience really strong shaking, there are steps you can take to make your home much safer. Things like that, things like securing your home to the foundation. Always recommend non-structural retrofits, like securing your bookcases to the wall, securing things to the shelf. These will really help in a situation of an earthquake. So moving on quickly, you can see this. This was some damage that occurred in the 2001 Nisqually earthquake. A lot of this damage in Pioneer Square happened to a type of building we have in Washington, unreinforced masonry buildings. So these are buildings that it's masonry, it's brick, and it's unreinforced. It doesn't really include any rebar in it to things like that to enforce the structure, and it's not secured to the walls, to the floors. So you can see here, when this started shaking side to side, because it wasn't stuck on the wall, and it peeled off the top parapets there. This is another reason it is really not safe to run out of buildings, whether it's this falling bricks, whether it is breaking glass falling. Running out of this building puts you in the most dangerous place. In addition to, if you're on a top floor, you have to run down stairs, which have a whole bunch of really sharp edges on them. Really dangerous place to be when the ground is shaking back and forth. Staying in the same place, especially if you can take cover under something sturdy, always a safer option during an earthquake. I'm going to show an example of how quickly this happens in a video. Watch this building up in the upper right-hand corner here, and just how quickly that wall peels off. This comes to us from New Zealand and some of the earthquakes that occurred after 2011, after their Christchurch earthquake. It'll show that one more time, just so you can see ground starts shaking. These people move to a safer place. Unfortunately, our friends in New Zealand are significantly more used to earthquakes. This happened in a period where there were thousands of aftershocks, very close to the surface, intense shaking. Yeah, I'll just let that play a couple times to see how quickly this can happen when the ground starts shaking. So you want to get somewhere safe as fast as you possibly can. Try to move forward here. So, you know how quickly that can happen. I would like to make sure everybody is aware of a tool that we have that can actually give you seconds of warning before that shaking arrives to you, potentially. Now, the USGS worked together with Washington, Oregon, California, all sorts of universities to create the Shakeout Earthquake Early Warning System that is available all over the US West Coast now. So how this works, this is not earthquake prediction. This is basically shaking prediction. It determines that an earthquake has occurred, and it sends alerts out to areas that are going to receive shaking of a certain intensity based on that earthquake occurring. So how it works, earthquakes produce P waves and S waves. So P wave is basically a sound wave. It moves really quickly, but it doesn't do much damage. You might feel it, you might hear it, but it's not going to cause much damage to things, usually just a slight rattle. S waves or secondary waves or shear waves, these are the more damaging ones that come through, and surface waves following them. They move about half the speed of a P wave. So if we have a really dense seismic network, like the Pacific Northwest Seismic Network has been building for the last 16 years across Washington, it can detect when some of these P waves move through and quickly calculate the magnitude of the earthquake and a basic shake map for where the shaking is going to occur. And we can send out via the wireless emergency alert system, via Android built-in systems, via the MyShake app, if you download that. Those are our 3 ways to receive this in Washington, but you can get alerts on your phone that say shaking is coming, drop cover and hold on. Now, based on their studies, in most cases, this is only going to provide 10 or fewer seconds of warning, just based on our earthquake situation. Whether it's Nisqually, it can only travel 30 miles. That doesn't provide much time, but that much time before an earthquake is significantly better warning than you would get. And a lot of times when you watch what people do during earthquakes, there's some really good CCTV footage. Sometimes they spend the first few seconds that they could be spending protecting themselves, wondering, is an earthquake going on? So getting that warning can really help you confirm. We want everybody to understand this, that you can get these alerts so you can practice and take action as quickly as possible. If you get one of these alerts or feel shaking, drop cover and hold on to protect yourself. So you can see this warning can also be sent not just to people, but to critical infrastructures, which can really help with recovery afterwards. It can do things like slow down trains so that the people on board aren't injured. It's not as fast when an earthquake happens. It also prevents the train from being damaged, which is really helpful. You don't have to replace a train after an earthquake. We currently have this working in Washington for some water and wastewater systems, shutting down pumps, shutting down valves to make sure that there's water supply after a large earthquake. These are really important implications for making sure that really important infrastructure is available after an earthquake. So we have 3 ways we can receive this. I mentioned them before. Wireless emergency alerts. This is the same system. You get Amber alerts. If you enable those on your phone, you can receive these seconds of warning. However, in testing, wireless emergency alerts have been the slowest. So what I would recommend to you is if you have an Android phone, enable the Android alerts. If you have an Apple or iPhone, they don't have any built-in alerts, download the MyShake app. So you can download that, it's free. It can use your location services, or you can actually just set your home location and it will warn you when an earthquake is going to shake above a certain intensity in that location. Android, you can search your phone for earthquake alerts. If you don't find it there, search location settings. They do keep changing it, but it is there on your phone if you have a newer smartphone. So both these are the fastest, and when you only have seconds, you want the fastest alert possible. Otherwise, you can get it here, but it's really spread out. So we highly recommend that you visit our mil.wa.gov/alerts page, which we'll make sure is a link included later. To understand how to get these alerts, because this is a really important system that can potentially give you seconds to save your life, to protect yourself. And you can see some of the thresholds that are happening here. These alerts aren't going to go up for every earthquake, because otherwise you might get that whole boy who cried wolf situation where you are over alerted for earthquakes. WEA is only going to go out for higher than magnitude 5 earthquakes that are going to shake where you are, higher than intensity 4. MyShake app only magnitude 4.5 and above for shaking that is weak or greater. Now we don't have too many earthquakes in Washington to test this on, but these are the magnitudes and the intensities that are going to be used for it. Android will actually send you a smaller alert that doesn't take over your whole phone. For smaller MMI 3 and 4, but if it's going to be 5+, it is going to take over your entire screen, and it's going to let you know, please, you need to do something now. So they're a little different. You can find this graphic on our mil.wa.gov/alerts page as well. So yeah, we just have this GIF on the side showing you exactly how quickly you can get an alert. You can get onto your desk. It only takes seconds. You have only seconds, but it only takes seconds to protect yourself. So please, if you do that, you got to use it. We actually have seen some CCTV footage of friends in California who have gotten a lot of times to test the system for us. They use the same one. It's run by USGS Shake Alert. But there's a lot of videos of people who get the alert right before the earthquake, and they just show their friends. They say, look, I got this weird thing, and then the ground starts shaking. We want you to actually understand that this alert is coming. When you get that alert, take action. You can tell your friends to take action too. Just take action quickly. Drop cover and hold on. Say practice makes perfect, and there is a great shakeout coming up on October 20th at 10:20, and you can practice. So coming to this one more time, what to do when you feel shaking or when you get an alert: drop, cover, and hold on. And again, this varies based on your situation, but the overarching principles that will help you wherever you are. Dropping, you're getting close to the ground. You want to get to the ground of your own volition. You don't want the earthquake to throw you to the ground. That's how people get injured. Cover your head and neck. They're important. And take cover if possible. That's what that means. If you have a sturdy desk to get under, people say get under a table, but if the closest table is a glass coffee table, please do not get under that. That's not going to be safe if something breaks. Take cover away from something that can fall on you, and hold on. Now, the Nisqually earthquake, a lot of people say it felt like it lasted a lifetime. That was 30 to 40 seconds of shaking. Our Cascadia subduction zone earthquake could last 5 to 6 minutes of shaking. It is going to be really hard to judge how much time there is, but you need to hold on to that cover. If you are under something the whole time, you need to stay where you are as long as it's safe for that entire time, because keeping that cover ahead of you or above you, even if it's trying to shake away from you, is going to be really important to staying safe. Another thing is if you have trouble getting down to the ground yourself, we know there's some people with mobility issues. You want to make sure that you are holding onto something tightly, again, trying to avoid being thrown to the ground somewhere, if possible, away from something. We also suggest lock, cover, and hold on. If you use a wheelchair or a walker, something that'll prevent you from moving as much as possible. But yeah, if holding on means being sure that you are not thrown to the ground, hang on to something tightly. So yeah, a few other examples here, and we have some really good videos of this, what to do in different situations on our EMD Prepared YouTube channel. Just to move forward. Oh, perfect. So that's all. One more plug, www.shakeout.org/Washington. Please join us for the drill. It is a great time to practice what you would do during an earthquake in Washington, which we could have. There's a possibility. And I think we actually just had one in Forks a little while ago at magnitude 3.5. Probably didn't bother too many people, but we like the small warnings that you should practice for the bigger ones. So join us at 10:20 on 10:20 and drop, cover, and hold on. And I think it's also a good opportunity to practice your tsunami evacuation routes if you are in a tsunami zone. I'm going to introduce my colleague, Alyssa Tapero, to actually tell you about those. So here we go.
Thank you, Brian. Hi, everyone. My name is Alyssa Tapero. I am one of 2 tsunami program coordinators with Washington Emergency Management Division. And we have such a large tsunami program because Washington is earthquake country, and that means we are also tsunami country. So you probably have heard when we talk about that big one, that big earthquake on the Cascadia Subduction Zone, that is going to be followed very quickly on the outer coast by a large tsunami. So those are one hazard that we really need to be aware of anywhere on our coasts. So tsunamis are essentially caused by any displacement of a column of water in a large body of water. So we typically understand them and experience them in oceans, but they can occur in seas, in lakes. Very, very small ones can, occur in, bathtubs and swimming pools, things like that. But they are caused by that displacement of the entire water column. It's usually by an earthquake, but it can also be caused by landslides, volcanic eruptions, certain weather events, meteors, which hopefully none of us will ever experience, anything that moves that column of water. So the video I've got going here is showing the tsunami that we would experience, the Cascadia Subduction Zone. So Brian was talking about how that subducting plate, catches our North American plate, builds up all of that pressure. And then when that pressure becomes too much, that plate sort of snaps up again. And it's the movement of that plate that lifts that entire column of water above it. And that's potentially as much as 2 miles of water that is lifting up, and then that comes down and ripples outward the way it would if you threw a rock into a pond or something. So those waves ripple out in all directions, which is why for us, the Cascadia Subduction Zone earthquake and tsunami would be a local tsunami, but it then travels across the Pacific Basin. It becomes, a distant or orphan tsunami for Japan, and for all of those other nations across the Pacific Basin. So these are a series of waves. It's not just one wave, but a series of very long, multiple waves that can last anywhere from 12 to 24 hours, or potentially longer, depending on how big the event is. One thing to also keep in mind with tsunamis is that once those waves have dissipated, the currents that are associated with them, those higher currents, can last even longer. The first wave is also often neither the highest wave nor the most destructive. Some of our modeling shows that for Cascadia, it's potentially the 3rd or 4th wave that's the largest. And those subsequent waves can be more destructive, not only if they are larger, but because they have picked up so much debris and they have already caused destruction. So that's why it's so important. I'll talk about this in a little bit, but so important to stay out of the inundation zone until local officials tell you it's safe. Because if we return to the inundation zone too quickly, we can get caught up in those returning waves. Tsunamis are also very, very fast. When they are out in kind of the open ocean, caused by that big earthquake, they can move up to 500 miles an hour, so as fast as a jet plane. When they get closer inland and the wave starts to kind of stack up, they slow down, but they are still moving anywhere from like 20 to 30 miles per hour on land. And that's a lot faster than most of us can run. And because they are caused by events other than sort of the natural wind waves or natural tides, because it's that entire column of water, it's not like a normal wave. It's more like a moving wall of water or like a moving wall of cement. So they are very, very powerful. It's not something you can swim in or surf or anything like that. They pick up everything in their path. So that water has a lot of debris in it, sediment, potentially hazardous waste. And then they leave all of that behind. So even once the waves have subsided and everything is sort of safe in that way, we still have all of that debris, hazardous materials and things like that to deal with. So tsunamis for Washington are a low probability event, but they have a very high impact. Here in Washington, we are lucky or unlucky to have a risk for both local and distant tsunamis. So local tsunamis are essentially defined as any tsunami that is close enough to your source where the first waves arrive in 3 hours or less. So for Washington, that's usually something that causes the tsunami that's right here within Washington, within our borders or right off our coasts. If it's an earthquake that's causing that tsunami, it's one that we will feel. And that shaking, that ground shaking, is our primary warning that a tsunami could be on the way. It is our first warning. It is our best warning. It potentially is our only warning. In the event of something like Cascadia, where we have that 5 to 6 minutes of really intense shaking, a lot of infrastructure damage, there's a really good chance that some of our official warning systems that are in place may not be working after that. So it's so important that folks on the coast know that if they feel that ground shaking, that's your tsunami warning. Again, those waves for a local event arrive in less than 3 hours. Depending on what that event is, it could be far less than 3 hours. It could be, minutes, 10 minutes, 15 minutes, upwards to, an hour or two. I'll show a simulation in a second that kind of shows that. Because that tsunami is so close to us, we see more inundation, we see higher, more severe currents, because those waves haven't had a chance to dissipate any of their energy. So there's a much greater impact to our coast. Our biggest local threats are, of course, the Cascadia subduction zone off our outer coast. And then along our inner coast, so Puget Sound, Salish Sea, it's those crustal faults that Brian was talking about. So the Seattle fault zone, Tacoma fault zone, South Whidbey Island, a lot of those cross right over the Puget Sound. And if they cause an earthquake that's large enough, and that is sort of the right kind of earthquake, they can potentially cause a tsunami. So these local events are definitely a threat to both our outer coast and our inner coast. Now, distant tsunamis are ones where they are generating somewhere else in the Pacific Basin. Those waves usually arrive in 3 hours or more. And if that tsunami is caused by an earthquake, we don't feel that ground shaking. And so it's much more important that we get those official alert methods, because we don't have that ground shaking to warn us that something's on the way. There's less inundation and lower currents because of that, because those waves are taking longer to get to us. But depending on where that distant event is, we can still see a lot of inundation, especially on the outer coast. So those distant events are still very important for us to be aware of, to get our alerts for, and to act on, depending on what that event is. Our biggest distant threat, which feels pretty local for us, is actually Alaska. So Brian talked about how Alaska has big earthquakes all the time. They've kicked off a lot of tsunamis in our direction over the years. And while they are considered a distant event because we wouldn't feel that shaking, those waves would still arrive in about 3.5 to 4 hours. So much more time than Cascadia, but still not a ton of time for us to get folks out of the water and make sure that everybody's safe. Now, the one kind of blessing for that is that the inner coast, would not be nearly as impacted for those distant events, because depending on the angle the waves are coming from and the distance they have to travel, they either wouldn't really travel through the Strait of Juan de Fuca, or they would lose a lot of that energy as they did. So those distant events are much more of a threat to the outer coast than the inner coast, but we want to be aware of them no matter what. Brian already talked a bit about the Cascadia Subduction Zone. Just to give you a reminder, 700 miles long, breaks between every 300 to 600 years. Last was in 1700, so we have a between 15 to 25% chance in the next 50 years. That's not huge, but that is also not small. It's something we want to be aware of and be planning for on the emergency management side of things in an official capacity, but also just as folks who live here, visit here, have fun here on the coasts. We would have that, that 3 to 6 minutes, 5 to 6 minutes of intense shaking, followed by, for the outer coast, a tsunami within 10 to 15 minutes. And that 10 to 15 minutes includes that 5 to 6 minutes of shaking. So that's why it's so important on the outer coast that as soon as that shaking stops and it is safe to get up and start moving, that folks are practiced, that they know their routes, that they are ready to move as quickly as they can, because those waves are going to be on their way. We'll also see, permanent subsidence and uplift. So the way that we recognize and interact with the coastlines of Washington will permanently change after this event. It'll essentially be unrecognizable to us in some ways. That's something else that we'll have to reckon with. Also be a lot of large aftershocks in the weeks and months following, and then many more smaller ones in the years to follow. Japan is still having aftershocks from their 2011 event that was very similar to ours. So some of those larger aftershocks may be large enough to cause tsunamis of their own, or they may be large enough that they cause landslides that cause local tsunamis. So that risk is going to still be there as long as we have kind of those seismic events still going on. Cascadia has given us 41 earthquakes, or large earthquakes, in the last 10,000 years. We know that for a lot of reasons, like Brian mentioned, but especially according to kind of the measurement of underwater landslides. So you can see here kind of the timeline of human history, what Cascadia has been doing. The larger red bars are earthquakes of magnitudes 9 or higher, so really that big one. And then the smaller bars are 8 and above. So an event that would still be large enough to create a tsunami, but smaller at least than what we are planning for. So that gives you an idea of how often that's been happening. But you can also see here that these events don't happen, exactly every 300 years or exactly every 600 years. They happen when they happen. And so we can give an estimate of, every 300 to 600 years we're in the window, but we can't predict it. And that's why it is so important that we are prepared for this event, because it could be tomorrow, it could be 3 months from now, it could be 10 years from now. But we have to be ready, because it could still be tomorrow. So this is a truncated version of a really great simulation from the Washington Department of Natural Resources. You can find this online on their YouTube. This is showing, for that kind of Cascadia 9.0 simulation that we plan to, what those waves look like. So we've got that 9.0 earthquake on Cascadia occurring, and then we've got time sense earthquake on the bottom, sped up obviously, so in hours and minutes and seconds. And then you also have wave amplitude. So those warmer, darker colors going up to red are wave amplitude, so the height of the wave, the crest of the wave, at 10 feet or higher. So that's something to keep in mind, is that this particular simulation maxes out at 10 feet. That means some of those waves are higher. They could be 20 feet, 30 feet, but they are maxing out at that 10. And then the cooler colors going down into that dark blue, those are the troughs or bottoms of the wave. And so one thing we know from this modeling is that we're going to see the trough first. So if that 5 to 6 minutes of shaking was not enough warning for you, if you're on the coast, you'll also see that water pull away. And that trough is especially important for our maritime community to be aware of, because when that water pulls out, all of our ships and infrastructure are sitting then on the bare ocean bottom, and then that wave comes in and pushes them up on shore and causes a lot of damage. So we have a lot of these simulations. This is one for the entire coast, but we also have ones that kind of zoom in for different areas. Some of our outer coast locations up in the San Juan Islands. What I really love about this one is not just that it shows that this wave does travel all the way through the Strait of Juan de Fuca, up into the Salish Sea, down into the Puget Sound, all the way into Olympia, but it also shows that even just that first wave before the second one has kicked off, we see how when it gets into the inner coast, the waves start reflecting off of all of our, tight water channels and through all of those really narrow waterways. And not only do they start kicking up the currents and causing whirlpools, but they start reflecting off of each other. So we have that to deal with as well, and not just that initial wave front, but the waves bouncing off of things. So even though we have more time, that first wave is moving down into the Puget Sound at about an hour and a half, 2 hours, depending on your location. We still are seeing very high currents and, situations where if you were out on the water at that time, if we had ferries out on the water, that would not be very easy to navigate or to stay upright. So again, something to keep in mind. Outer coast, absolutely so important that once that shaking stops, that folks are getting to high ground. More time on the inner coast, but again, we will have just had this major earthquake that's caused a lot of infrastructure damage. And so even then, we want folks to know, okay, I got to get up and get going. Even if I have an hour, that's an hour that I don't want to waste time because I need to get to high ground. This is also from the Department of Natural Resources and is based on that same Cascadia modeling of a 9.0 earthquake and then the tsunami, but it's giving arrival times of those first waves approximate, since it is modeling, and then the approximate offshore amplitude of those waves. So this isn't showing the depth of the water on land, but it's showing how high those waves would be right offshore. This gives you an idea of what those arrival times might be. So we are seeing out on that outer coast, it really is in some locations 15 minutes, 20 minutes, an hour, not a lot of time. But as we move into the inner coast, we are seeing more like an hour and a half, 2 hours and a half, much more time to evacuate. So we have, all of these maps are available. We'll provide links. You can find all of this online, but be aware if you are someone who lives on the coast or just near the coast, or if you visit, you're in certain areas, check the maps, see if you're in an inundation zone or near one and what those arrival times are, just so that you know that in advance should something happen. So some of the impacts that we will see from a local event. Oh, I think my video is playing. There we go. Some of the impacts that we will see from the tsunami waves, along with the liquefaction and landslides, is damage to a lot of our infrastructure. So our fuel piping systems and pumps that are in the inundation zone will get munched up by those waves that are coming in and then scouring out, and all of that debris that they're carrying. We could also see power loss to systems that are outside of those zones because there are pump stations and providers that are within that inundation zone. So we could see cascading effects. We'll see a lot of damage to our bridges, overpasses, roadways, and other transportation infrastructure. A lot of our transportation infrastructure is aging, is getting pretty old. It's why you see WSDOT out there all the time, doing updates and trying to fix it up, make sure that it can withstand things like this. And then, of course, Washington is a maritime community. We have a huge maritime economy, and we will see damage to our port and marina infrastructure and goods, which will impact our ability to travel on the water, to ship things to and from Washington, and to our partners in Alaska and Hawaii, that kind of thing. So the 2011 earthquake and tsunami in Japan is kind of our best, most recent event that we can compare to what might happen here. It was a subduction zone event right off of their shores, so very similar to what we would experience. Very large tsunami hit them about 20 minutes after that ground shaking. They actually were more prepared in many ways than we are, but unfortunately they had based their modeling on a smaller event. They didn't think that they would ever have an event of that size, and so they saw a lot of destruction. So the videos I'm showing here on loop, they are both from that 2011 event in Japan, just to give you an idea of kind of what that inundation looked like, what they saw in a lot of their ports and marinas. You know, ships being washed out to sea. They saw a lot of damage to their roads and bridges. You know, more than 300 of their ports destroyed, a lot of ships, these huge whirlpools. So it's hard to see, but at the very end of the video, kind of to the very center, to the far left, you can see a tiny little boat there. It looks like it's a yacht, maybe, just to give you an idea of how big those whirlpools can be. And we know that we will see those because we've seen them on some of the modeling. So that's the event that we look to see kind of what it could look like here, just to give you an idea of why we show these videos. Again, so here are some other images from Japan showing sort of the aftermath and also the waves themselves coming in inland. The top right is a really famous one. That's the wave overtopping their seawall. So again, they had built a seawall. They had built to what they thought was kind of the biggest event that they would experience. And unfortunately, they had an earthquake that was much larger than that. And so it overtopped the seawall and did a lot of damage. You know, these waves are strong enough that they can lift huge tanker ships and other big vessels, deposit them many miles inland and things like that. And then this is a before and after the wave striking of one of their coastal towns. Their coastline isn't exactly like ours, but we do have a lot of low-lying coastal towns that don't have high ground nearby. So this is, you know, potentially what that could look like. And that's why it's so important that we build vertical evacuation structures in our coastal towns on the outer coast, and that we ensure that folks know where their evacuation routes are and that we can get them to high ground as soon as possible. As I mentioned before, our biggest distant threat is Alaska. So they've had a tremendous number of large earthquakes just in the last couple hundred years. They actually had one in 2018 that if it had been kind of a different kind of earthquake, if it had moved the earth in a different way, we would have potentially seen a fairly large tsunami from it. We are lucky that it just was not the right one, the right kind to generate one. But we have had a lot of observed tsunamis from Alaska in the last several hundred years. So they are the ones that we keep our eyes on. We've also had other recent distant events. So Japan's 2011 earthquake and tsunami was for them a local event. For us, it was a distant event. Kind of the most famous North American destruction was in California. California, just because of sort of what their coastline looks like and where they have their ports and marinas, they tend to get hit pretty hard when we have distant tsunamis. And so these are some videos from Crescent City, California in 2011. They had a lot of time, a lot of warning, and they still saw quite a bit of damage. So you can see that tsunami wave coming in, and you know, these boats are tied up. Fortunately, there's probably nobody in them, but that wave is still doing a lot of damage. And then we actually had a tsunami earlier this year. So if you were aware, on January 15th, the Hunga-Tonga Hunga-Hapai volcano erupted. We originally didn't think that it would be possible for it to create a tsunami, but it was actually the pressure wave of the eruption that created a tsunami in the Pacific Ocean basin. Is that second eruption. And so we're under a tsunami advisory here in Washington for about 11.5 hours. You probably, may have heard that seen that on social media. We were pushing out a lot of information because it was an advisory and not a warning, which is that next highest level. I'll talk about that in a minute. We didn't mass evacuate or anything like that, but we did want folks to be aware to not be near the water for that. We didn't see any destruction here in Washington, thankfully. But again, California still saw some destruction, had some folks who were injured because they were in the water when those waves arrived. So they had waves of about 3 to 4 feet. Our waves were about a foot, but we did see waves. They had about $6.5 million in damage to Santa Cruz Harbor, and then about $1 to $2 million in damages in Ventura Harbor. So again, to that maritime infrastructure that even when we don't have a lot of inundation, we can still see a lot of damage. These two videos I borrowed from Twitter from that day because I think they're such great examples of the kind of impacts we can still see from those distant events. So the video on the left is just, looking out along up here, and again, these are just waves of about 3 feet. A lot of folks on social media that day were saying 3 feet. I see that all the time. That's fine. But these waves, you can see, have a lot more power behind them than normal tide waves or wind waves. There's so much force behind them that even if it is just a foot or a couple feet, that's not something that you want hitting you. And then this other video on the right is from Santa Cruz Harbor from the marina. And you can see that it has been inundated quite a bit from those 3 to 4 foot waves. And the thing about this is that that water looks really placid. It looks like you could wade through that pretty safely. It doesn't seem like it's moving very fast. But when the video zooms in, you can see in the back where the parking lot is that not only is the water deep enough, but it's moving fast enough that it's lifting up some of those vehicles and kind of bobbing them around in the parking lot. So that means that water is moving a lot faster than it looks like. That water is also pretty opaque, which means that we can't see what's in it. So there could be all sorts of debris in there. We know based on their kind of after action reports that a lot of the electrical boxes that were in the marina area were inundated. So it could be that there's, live electricity in the water. If there were any boats that were destroyed, if they had any solid waste on board or any chemicals like that, those chemicals could be in the water. So even though it looks safe, that's not water that you want to be in. That's not water that's actually safe. So as I said before, it's so important for us to know those natural tsunami warning signs and then the official warning signs, depending on what kind of event it is. So obviously, if we experience the ground shaking here, that's our best warning. It's our first warning. It's our best warning. It's potentially our only warning. So if you are on the coast and you feel ground shaking, don't wait to try to figure out, is this Cascadia? Is this a Seattle fault scenario? What is this? Just assume that a tsunami is going to be on the way because you felt ground shaking. When it is safe for you to move, get to high ground. And if it was a small enough earthquake that nothing was generated from it, then you've practiced your evacuation route. And if something was generated, then you have taken the steps necessary to keep yourself safe. However, if the tsunami was generated somewhere else in the Pacific Basin, there are other natural warning signs we can look for. So if the trough of the wave is leading, you might see the waves pull out very quickly, much faster than a normal tide would pull out, so fast that you might see like fish flopping around and other ocean creatures that have been left behind. You may see the waves kind of just behaving abnormally. A lot of us spend time by the water. If you were born here, you were raised by the water. And so many of us kind of are used to seeing what the water does each day as the tide comes in and the tide goes out. If the water seems to be behaving weirdly, it's frothing or bubbling or doing something like that that just seems abnormal to you, gives you a weird feeling in your gut, that might be a sign a tsunami's on the way. And again, it's better to get to high ground and have practiced your evacuation route when a tsunami wasn't coming than to think, no, I'm probably, just being paranoid, and then to not get to safety when we're actually noticing the warning signs. You may also hear like a loud roaring sound coming from the ocean. That's the wave approaching. So any of those things that you observe that seem weird or get that kind of ice cold feeling in your gut, listen to that, because that could be something coming and we want you to get to safety. Of course, there are also official alerting methods, and we want those to get to you as well. We don't want you to have to rely on, watching the water and seeing what it's doing. There are many ways to get tsunami alerts, and we want you to be signed up for many of those ways. That way, if one of them doesn't work, if your phone is roaming because you're on the outer coast and reception there's terrible, or if you don't have your TV on and you can't then get the news report, you have other methods. So, as Brian mentioned before, we have all of these different alerting methods at our website, mil.wa.gov/alerts. That's not just for tsunami alerts. We go through, ways to sign up for local alerts, for volcano alerts, for earthquake early warning, all of that. But there's a nice big section about the different ways that you can get tsunami alerts. So some of those will come to you through your phone. Brian talked about wireless emergency alerts before. Many of our coastal counties send out alerts through the kind of local alerting methods that they use. And there are other apps as well that you can use. I really like the NVS Tsunami Evacuation app. That's for both Washington and Oregon. So if you live in one and visit the other often, that's a great one to use for both states. Social media is also a really good one. I know that sounds weird, but the National Tsunami Warning Center, when they push out their alerts to everybody, they push out their alerts to Twitter. And oftentimes I get the Twitter notification before I get any other alerts. It's that fast. So that's not a bad one to follow as well. If we are under a tsunami warning and you happen to have the radio on or the TV on, or you are somewhere where they're on, you may see that scroll alerts, the emergency alert system. You might see that. If you have a NOAA weather radio, you'll get alerts through there. That's a really great method, something that everybody should have in their home, in their workplace, because that's not just tsunami alerts, that is all weather hazards, all kind of public safety. It's a great way to get all sorts of alerts. And a lot of NOAA weather radio receivers can be programmed to act like smoke detectors. So you don't have to have the radio part on all the time. It can be silent, but they're constantly scanning for hazards in the way that a smoke detector does for smoke. And then if it picks something up, if it says, oh, you're in Grays Harbor County and there's a Tsunami Advisory suddenly going out, you can program it to make a nice loud sound, as loud as you want it to be. That'll wake you up if it's the middle of the night, or if you're hard of hearing and you need something that's going to make a really loud noise. Those are a great thing to have. We also, along the inner and outer coast, have Tsunami Sirens. So you may have seen those if you're visiting. They are usually right on the water or very close to it. They look very similar to the image here. They're usually a stack of 7 white speakers. Can't miss them. They're very big. Those are intended as an outdoor warning system only. So the sirens are intended for folks who are right on the water, especially our beach goers who are maybe visiting for the day or something, who might not have a NOAA weather radio with them. Obviously, you're not going to have your TV with you. If if you have your cell phone with you, you might not have reception. You might not be able to get alerts through that. So these are not intended to be heard indoors. They are not intended to be heard for, a particularly long distance. You can usually hear them for a radius of about 500 feet, but that depends on the direction of the wind and if it's raining or not, and kind of the vagaries of Mother Nature. But they are intended so that if you are right on the beach and you don't have anything else with you, if you hear that siren, you'll know that something's coming. So we have all of these different methods. It's really important to be signed up for as many as you can. And again, mil.wa.gov/alerts walks you through signing up, because some of these methods are not as user-friendly to sign up for as some of the others, but we walk you through all of that. And as I mentioned before, social media is honestly a great way to follow for all of the hazards in our area, what's going on, a good place to get additional information. It's not the only place this information is being put out, but it is one method. So these are some of the accounts. We've got this also on our alerts page, but I do suggest, depending on where you are, following the National Tsunami Warning Center, and then either National Weather Service Seattle or Portland. National Weather Service Seattle serves kind of the entire Puget Sound and most of the Olympic Peninsula, and then National Weather Service Portland serves our very southern counties. And then you can also follow us on Twitter and Facebook. We are pretty entertaining, or we try to be at least. So we have our official WA EMD Twitter and Facebook, and then our team, so Brian and myself and the rest of us here who do outreach, we also run the WA Shakeout Twitter, so we put information out there as well. Again, these are all on our alerts page, but if you're ever looking for information, these are all really great resources. I just mentioned the National Tsunami Warning Center. So here in North America, all of our tsunami alerting and kind of watching out for tsunamis is done through 2 warning centers. So the National Weather Service operates these. There is one in Alaska, the National Tsunami Warning Center in Palmer, and they issue all tsunami products for Alaska, British Columbia, Washington, Oregon, California, essentially all of North America. So if we are under any sort of tsunami alert, it comes from them. All updated information and instructions come from them as well. So if you are looking for information, you're looking for, the bulletins to read what's going on, how does this affect me? You'll want to make sure you're looking at the information coming from the National Tsunami Warning Center. We also have the Pacific Tsunami Warning Center in Honolulu, Hawaii. And as you can kind of see on this image here, where they are all of the yellow coastline, they serve essentially everybody else in the Pacific. So they are the International Warning Center for 26 member countries and Hawaii. So if you're here in Washington and you're looking for tsunami information, do not pay attention to what Pacific Tsunami Warning Center is saying. They do not issue alerts for us, but they do issue alerts for Hawaii. So what is the process for issuing a tsunami warning or for any other warning or any other alert? So if the initiating event is an earthquake somewhere in the Pacific, that event happens, that earthquake happens, and the tsunami warning centers have automatic seismic sensors that alert them that an earthquake has happened. And then very, very quickly, in seconds to minutes, it's initially located and then sized. So where did this earthquake happen? How big was it? And that information is then compared to a massive historical database. So, based on modeling and historical events like this, what are the chances that this could cause a tsunami? So they compare it to all of that, and then within 5 minutes of that earthquake, the tsunami warning centers issue their bulletins with alert levels. So if their system, comparing all of that information, says, yep, there's a chance that this earthquake could have caused a tsunami, then they send out bulletins that potentially put us in, a tsunami watch or a tsunami advisory or warning. If it's a very small earthquake and they know that it's not going to be large enough or the kind of earthquake that can create a tsunami, then they'll send out an information statement that says, yep, there's no danger to the US West Coast. If that system says, yes, there is a chance that this event could have caused a tsunami and it is close enough to Washington or to any location, but let's say Washington, that we would be within a 3-hour window of those first waves arriving. So potentially if Alaska has a big event, they're going to put us straight into a tsunami warning. They may not necessarily know a tsunami has been for 100% sure created yet. They just know that earthquake could cause one, but they want to give us enough time that we start evacuating folks if we need to, that we are setting off the sirens, that we are getting information out. Because it can take a while from that earthquake to the time where they know for sure if a tsunami has been created or not. And that's because they are essentially in that time, 45 minutes, an hour, hour and a half, depending on the location. They're waiting for that potential wave to hit tide gauges and dart buoys across the Pacific. Sometimes that happens pretty quickly if the initiating event is near where a lot of those are clustered. Sometimes it happens in an area where we don't have a lot of those nearby. And it takes a while for that wave to get somewhere where we can say, okay, yep, it hit the dart buoys. We can see that a wave was generated, or more often than not, we can see that nothing was generated. If we know for sure that no wave has been recorded, that nothing was cause, then if we're under a warning, it's canceled. If something has been generated, then we start getting updated information. They say, yep, we know it's hit the tide gauges. We're starting to get an idea of the size. We're starting to get an idea of when it's going to arrive, information like that. But that takes a while. I say that because it can be very frustrating for us and for you, the public, to wait in that time. We get that first, after 5 minutes, we know that they've sent out that first bulletin, but then it can take a while for us to get some good hard information after that. And that's something that we are always working to kind of narrow that window as much as we can, but it's just a matter of waiting for that wave to hit something where we can get some information on it. I've mentioned the tsunami alert levels. So here in the United States, so as part of the National Tsunami Warning Center and the Pacific Tsunami Warning Center, we essentially have 4 different alert levels. The lowest is that information statement I mentioned. It means no action needed. So that tends to go out when we have smaller events that could not cause a tsunami, but the tsunami warning centers know that people are going to be wondering about it. Maybe because it was a particularly big earthquake somewhere else in the Pacific, or it was a smaller earthquake, but it was really close to us. Something that might make people nervous. They want to make sure that they are putting information out that says, yep, everything is fine. We get those all the time. If you follow the National Tsunami Warning Center on Twitter, you'll see that those go out on a daily basis or maybe even a little more often, depending on how active Earth is being. That's the most frequent. When you get one of those, for the most part, like, we're good. The next step up is a watch. Watch essentially means be prepared to take action, stay tuned to local radio, to your NOAA weather radio if you have that. More information will follow. That usually means that a tsunami is possible. An earthquake that was large enough to generate a tsunami has occurred, but they don't have quite enough information yet to tell us if that's going to be a threat to our particular coastline. That is one where that alert level will change once more information is known. So that watch will either be upgraded to an advisory or a warning, or it will be canceled. It's always going to change somehow, which is why we want folks to keep paying attention. So if you are, if we're under a watch and you are on the coast, we want you to make sure you know where your go bag is, just in case you have to evacuate and have your TV on, or whatever your alert method is, getting it on your phone. Just be prepared and pay attention. The next step up is an advisory. So that's what we were under for 11 and a half hours with Tonga. Advisory essentially means that either we know something is coming, or we are pretty sure something is coming, and that we are expecting waves between about 1 to 3 feet. So we don't necessarily expect a lot of inundation with an advisory, but we do expect some pretty large waves out in the water, high currents. So this is something that is especially important for the maritime community and for folks who are right on the water for whatever reason to pay attention to. So we tend to tell folks, we're under an advisory. That means stay out of the water, stay away from shore. If you are on the water, get to shore and, move out of that kind of inundation zone, get to high ground. But you won't hear the sirens go off. You won't hear, WIA and things like that necessarily for an advisory. Tsunami warning, which is the one that you're probably most used to hearing about, that is that high level. That usually means that either we expect that something big is coming, or we know something big is coming, or we've had that big event somewhere close by, like Alaska, and although we're not sure yet, we want to make sure that we are starting that evacuation process. So we are expecting more inundation, potentially higher waves, 3 feet or more. The sirens will be going off. You may get a wireless emergency alert. More communication methods are being utilized because we may be trying to get a lot of folks out of that inundation zone. And I'm going to skip through these. So whether you feel shaking or receive an alert, as Brian said before, it's important to know what to do. If you feel shaking, once that shaking is done and you are safe to move, you're gonna grab your go bag, which I'll talk about in a second, and you are going to walk or run if you need to, your tsunami evacuation route to high ground. I say walk or run because we don't want you to plan to evacuate by car. One, because if it is a local event, there's a really good chance that our roads are not going to be passable for vehicles. There are going to be power lines down and the pavement's going to be broken up. There might be trees and washouts and things like that. There's a good chance you're not going to be able to drive. And so we don't want you to rely on that. If we have a distant event where the earthquake's not going to destroy anything, we still want you to plan to evacuate by foot if you can, because we want to leave the roads open to emergency vehicles, to folks who have to get to a hospital or, to other things like that. We don't want to fill the roads up, which we have seen in the past, like in 1964 with the big Alaska tsunami. So if you are able to, please evacuate by foot. If you are not, please have a backup plan. You will be able to evacuate by car if we have a distant event, but again, that's not necessarily going to be an option if we have a local event. Once you get to high ground, we want you to stay there until local officials tell you it's safe. So the state's not going to tell you, the National Tsunami Warning Center is not going to tell you, it's going to be your local emergency management because they are the boots on the ground. They know, when the waves have stopped, the currents have stopped, when that area is safe, because we may still have, landslides, we might have fires, depending on what the event is. So we want you to stay out until it is safe for you to return. And they're the ones that are going to tell you that. That's why it's so important to be signed up for your local alerts. And lastly, evacuating takes longer than you think. That's why it's so important to know your closest evacuation routes and know if there's a map for your location. We have a lot of these tsunami evacuation walk time maps, especially for the outer coast, but also for inner coast locations. So if there's one for your area, that's a great way to figure out where high ground is and where you need to go. You can find those at mil.wa.gov/tsunami, or you can look up your address on WA-DNR's geoportal, which I'll talk about in a second. We want you to have your go bag packed and ready so that you aren't stuffing things in it while that wave is arriving. And we also don't want you to look at any secondary sources to confirm if that tsunami's coming. So if you feel ground shaking, evacuate. If you get an alert that says to head to high ground, evacuate. Don't call your friends and ask if they got an alert. Don't check on, ask your neighbor, hey, did you see this? Don't confirm with secondary sources. Believe that first alert and get to high ground. And please practice, practice, practice. You might be evacuating at night. You might be evacuating after 6 minutes of intense shaking that's rattled your wits. You might be evacuating in situations where it's just, you're not calm and it's not easy to see where your route is. So we want that to be as instinctual as possible, that you're heading where you need to go.
Wildfires are
I'm actually going to skip that because we're running low on time. Wildfires here are becoming a much larger issue, and that is just another reason to sign up for your local alerts, because that is the best way to find out about any fires that are in your area, whether you do need to evacuate or be ready to evacuate for something like that. Another great reason to follow the National Weather Service for Seattle or Portland on social media or through other ways, because they are always providing information about smoke and air quality and things like that. Even when we don't have fires near us, just that air quality impact can be really bad for us. So please pay attention to that, and do not push yourself when we are having that bad air quality. Don't go running. If you don't have to, don't do hard labor outside. Please be careful, because that can have really bad long-term effects. And finally, when we have these big events, plan to be on your own for a while, especially something like a Cascadia earthquake and tsunami is going to cut a lot of our communities off, especially if you're in a rural area, outer coast. There are a lot of communities that have just one road that goes in and out. Highway 101 is a lifeline for a lot of our outer coast communities, and it runs right along the water in a lot of places, runs through a lot of high liquefaction areas, places that have a high landslide potential. So there's a chance that you and your community will be the ones responding for yourselves for days or weeks. So be ready for that. Know how you'll get alerted. Know that you have a family emergency plan and a plan with those that you love, friends and neighbors. Be ready with your go bag and be sure that your go bag is not too heavy for you to carry if you are evacuating on foot. Know your evacuation routes and practice them, and know how you're going to be able to communicate and reunite with your family. So, do you have backup reunification places if you can't get to the, option A? Do you have option B? Do you have someone who is out of the area, not just out of, the general area, but out of the state, maybe on the other side of the country, that you can all communicate with, who will be unaffected? And then are you involved with your community and making sure that you as a community, as a neighborhood, as a little cul-de-sac collection of homes will be able to respond together.
Preparing.
So you've already learned about your hazards. That's kind of the first step. Know what kind of things you could be responding to around here. Earthquakes, landslides, volcanic eruptions, tsunamis, those are the big ones. But on the kind of day-to-day, we also have, droughts and floods and storms. We're moving into the fall and winter. We'll have a lot of rainstorms and windstorms that will cut our power out at the very least, and sometimes cut us off from being able to get out and around with trees falling down. So be aware of what in your area can possibly occur. Make a plan, practice that plan, know what your plan is if you are away from home. So what are you going to do if you're at work? What are you going to do if your kids are at school and they are, across the city? Or what are you going to do if you, like myself, live in Gig Harbor, work in Tacoma and the bridge is down? Have those plans, know what you're going to do and how you're going to communicate. And build your kits. We used to say be ready for, have enough for 3 to 5 days at home. Now we're saying 2 weeks. That's 2 weeks worth of food and water and all of the essentials that you need to stay home in place, be comfortable, have your medications, keep your pets fed and safe, your kids, everybody. And then also have those go bags at work, in your car, anywhere that you spend a lot of time, so that should something happen when you're not home, you can take care of yourself for, a day or two at least, just in case it takes you that long to get to a shelter or to some place of safety. We have a lot of great materials to help you out with this, including our Prepare in a Year guide, which walks you through getting prepared in all those different ways. Over the course of a year, you can do it faster if you want, but completing one activity a month, it's usually just takes about an hour, so it's a very small amount of time. Getting prepared over time is a lot easier than trying to do it all at once. That's just overwhelming and can be expensive and scary. So just take baby steps. We are all somewhere in our preparedness journey, even us at Washington Emergency Management Division. There's always stuff we're working on, can always be better. So just take those first steps or the next step if you're somewhere else in your journey. And we've got lots of materials for you to do that. And then, of course, think about once you feel like you are really prepared, are there others in your community that you can help? The Geologic Information Portal I mentioned before, this is a really great resource for figuring out, where you live or work or spend time, what the hazards in your area are. So it's dnr.wa.gov/geology portal, but if you search, WA DNR Geoportal on Google, you'll find it. You can look up exactly what your hazards are. Are you in a Lahar zone? Are you in an tsunami inundation zone? Or do you live on land that is susceptible to liquefaction? You can find all of that here, along then with the evacuation route maps and any other mapping that's associated with that hazard. Brian mentioned before, are you registered for the Great Washington Shakeout? That is coming up on October 20th. That is the largest earthquake and tsunami drill in the world. You don't have to do it that day, but we do ask you to register even if you're not planning on doing your shakeout drill that day. Practicing drop, cover, and hold on is super important, as he mentioned before. Something to note, Shakeout is also the one day of the year that we test all of the tsunami sirens with the actual wailing sound. So the big, scary siren sound that will go off for a tsunami warning also will go off on Shakeout. So be aware of that if you are anywhere near a siren, or if you just happen to be on the coast that day. The sirens will make that sound at around 10:20 a.m. Could be a little later, but it will be that morning. If you hear that, please don't call 911. They are supposed to be doing that. But if you have the chance to then practice walking your evacuation route, that's a really great opportunity. You can participate in Shakeout as an individual, as a family, as your business, or, organization, schools, local governments. We're all taking part. We are trying to hit 1.5 million or more participants this year. We are always trying to beat California in at least percentage of the population that takes part. We can't beat them in population itself, but we try. So check out shakeout.org/Washington to learn more about that. Our team's also very happy to give you ideas for how to take part. And finally, we've got some links here for you. So mil.wa.gov/alerts is all of our alerting information. mil.wa.gov/preparedness is everything you need for getting prepared as a individual, as a family, as an organization. And then shakeout.org/Washington, again, is the Shakeout website specific to Washington. So you can register there, find all sorts of cool resources. Because we have been talking even more than we thought that we would be able to, if we do not get to your questions in the next few minutes, you can send them to public.education@mil.wa.gov. That reaches our whole team. We are always happy to answer questions, to help you find resources, to walk you through using some of the online resources that are not as user-friendly as some of the others. So if you have anything that you need or want or are curious about, we are always happy to answer questions. And with that, we have 10 minutes to answer questions, although we can go over. That's just the official time. So we will open it up to questions that have been submitted through the Q&A.
Awesome. So I'm Holly, and I am on my 4th day here at EMD, but I came to us from Hawaii Emergency Management Agency, so I'm familiar with some of the hazards, and I look forward to working with many of you. Here are some of our questions. So the first one I included because I think this is really important to understand sort of what we do as emergency managers. So the first question is, how freaked out were you all when that venting thing happened on Mount Rainier a few weeks back?
That is an awesome question, because Brian actually is our resident volcanologist, and much like happens when the resident expert on something happens, like he was on vacation, of course, when that happened, and I was a little concerned when I first saw it trending, but I will let you answer because you stepped in and saved the day, even though you were on vacation.
Sure. So as I mentioned, we have 5 active volcanoes here, and that activity looks different for each volcano. And this is kind of something we actually see at Mount Baker a lot, but also other volcanoes, Mount Adams as well. Occasionally people call in because they think they see something unusual. Mount Baker almost constantly has a steam plume coming from it. We can only see it when the atmospheric conditions are right, really cold, clear days. So sometimes when that happens, people call in and say, Mount Baker's erupting. However, what I know and what I hope you can take away from this is that it's really important to go to the experts who are monitoring these so that you can actually find out what's happening. Those kind of reports, sharing that information, if you see something, say something, applies to your volcanoes as well. So yeah, please reach out to your local emergency management, to the observatory if you know how to contact them if you think you see something at the volcano, because recommend not actually trying to tweet that information if you're a forecast meteorologist or something, because that is what causes people to think. But go to the experts, please, and let them know that you see something, and then they can investigate because they have the background to tell you what's going on about it. So not too freaked out, but definitely like, maybe we're in response mode here. Let's see what's happening. But I had not. I looked at my volcano notification service. They send things directly to my email, did not have an information statement about that. So that right there, huge load off my mind that they hadn't noticed anything unusual at the volcano. Our volcanoes will not erupt without some sort of notification because they don't currently have that magma, and magma needs to show signs that it's moving up in the volcano. So hope that helps.
Thank you, guys. Okay, our next question. This one is a tough one. For emergency preparedness, what do you suggest for preparing emergency medication supplies when most people cannot get extra prescriptions because it's not allowed?
So that is a great question, and unfortunately is one we don't have a great solution for. I have heard that you can essentially do the thing where, you fill your prescription, you have, say it's a 90-day prescription, you've got 90 pills. As soon as you can fill that prescription again, fill it, and then set aside whatever extra pills you have then from that first prescription, and those become your extras. I have not tried this myself. I have many prescriptions, but I have not tried this because the problem with that is that you then have to keep track of, okay, these pills have an these 6 pills have an expiration date of this, and then ones that I will get next time have an expiration date of this. I have a good memory for some things, but I don't have a good memory for something quite as complex as that. If you are really dedicated, that's definitely a method to try. That's really the only other suggestion I've heard besides, asking your doctor if you can get extras. I have heard suggestions of, try to get, speak to your doctor or to your insurance about getting specifically like an emergency dose or something like that. I don't know if anyone's had a lot of success with that. It's obviously going to depend on the medication. Some are much easier to get in a more dosage than others. The only thing I can really truly recommend is making sure that in all of your go bags, potentially also, on your smartphone or on your person with you, you have a list of those medications, exactly what dosage you take, how often you take them, what you take them for, whatever information you are comfortable carrying, the name of your doctor, your insurance information, all of that, so that if we have something happen, the minute you get to a shelter, they can help you to start trying to fill that. It's going to obviously depend on the kind of event we have, but that is something that shelters and especially the Red Cross will be able to help with, is filling those medications, especially if they are life-saving medications or ones that you cannot be off for an extended period of time. The more information you have, the quicker you can start trying to fill those. But it is very tricky. We don't have a great solution to it yet. I am very aware of that.
Thank you, Alyssa. Yeah, a lot of people will do a thumb drive, or now since we have the cloud, those things are a lot easier to carry mobily with you in a safe place. Awesome. Okay, our next question, this one would be for Brian. When you say get to higher ground, and this was talking about specifically the Lahar, can this mean even heading towards the volcano for higher ground? Obviously still not entering the Ash and Lahar zone, or just run to higher ground opposite the volcano, even if it's much further away?
That's a good question, and that's part of the reason we like people to, as Alyssa said over and over again, learn your routes, practice ahead of time. Again, if there's a volcano erupting, and that's the reason there's a Lahar, you probably don't want to go towards the volcano. It is going to be the highest ground around, but you want to find safer high ground. Now, a lot of communities are working on this, where they actually have volcano evacuation route signs. Pierce County has been really good at this, places around Mount Baker and Glacier Peak as well. Yeah, I would say, and one thing we haven't mentioned as much is, for all these, we work for the state. We cannot remember every detail of every community, but you do have a really good resource at your disposal, your local emergency management, whether that's your city or your county. We should definitely be in contact with them about your local hazards, because they're the ones that are going to be tracking local evacuation routes. And a good thing to look up is if you commute through an area that has those Lahar hazards or tsunami hazards, try to find what the evacuation routes are in those areas too, because there's a possibility you'll be there when these things happen. So know how to get alerted, know how to get out if you need to. But looking those things up ahead of time and practicing them as much as possible, it sounds like a lot to do, but it really will take a load off your mind. Yeah, if you're ever stuck in traffic, just think about where you would go. Nobody ever gets stuck in traffic in Washington. Yeah, anything to add on that?
The only other thing I'll add is that our mil.wa.gov/alert site has all of the information for signing up for your local alerts, and that includes all of the local websites also for county and city emergency management. So that's a very good resource for finding that information for any hazard.
How to get alerted and how to contact them in the first place.
Perfect. Thank you, guys. There's only two more questions, and they both have to do with sort of our planning phases as emergency managers. So the first one is, how well are you planning with local health jurisdictions, for example, training for response?
So we definitely realized partway through a pandemic that we need to be working more closely with health. And that is something that we've really developed a better relationship with through the last 2.5 years, as everybody's been learning really how to respond to a pandemic. But I do feel that we have a much better relationship with the State Department of Health and local health jurisdictions. At the state, we're working much more closely with the State Department of Health, but it's their relationship with the health jurisdictions that's definitely grown over this. It's in disasters, it's not as much what you know as who you know. And definitely these connections have gotten much stronger, and we know exactly who to talk to about these different things. So that's going to definitely be a part of exercises moving forward, how to work with these agencies to get them what they need. And just, yeah, we're always building is probably the best way to put it. And we're always learning new things. Any disaster is a huge learning opportunity. But because of this, we have definitely made connections that will help us plan for future events and not just health-related emergencies. Because health is going to be a huge part of responding to earthquakes, to volcanoes, to tsunamis. So yeah, we learned a lot, building a lot, and it's going to help us in the future. Hope that answers.
It was definitely one of the benefit sides of COVID, is that it really did help form those relationships and cement how you deal with some of the cascading effects of hazards. Your final question is, what kind of community engagement do you do for non-technology using community members?
So we are often out in the community, doing a webinar today through Serve Washington, but we are often in the community now that COVID has at least scaled back enough that there are now community events, especially kind of spring, summer, fall. You often can see us in, like, local kind of emergency preparedness fairs, that kind of thing. We do a lot of in-person events if we are kind of invited in. Before COVID, we used to do a tsunami roadshow and earthquake roadshow. We think we did at least once. Those have not started up again yet, but we prefer, honestly, to do things in person if we can, although streaming them also is nice. So we do a lot of in-person presentations, a lot of in-person kind of booths at events, and other things like that. So we are in the community a lot. We also are happy to come out and kind of do smaller events, one-on-one, or kind of do, gosh, what's the word I'm looking for? Kind of like site visits, to go and, visit a neighborhood or a town and say, okay, these are kind of your hazards. Here's what we would suggest, kind of getting ready. Here are the resources we provide, that kind of thing. But yeah, if you're ever looking for us, especially out in the summer, we are at a lot of events, and we are always happy to come talk to groups, big or small, doesn't matter kind of where it is or what it is. I was in Forks just a little bit ago, talking to a group there. We are often on the coast, or at least my team is as Tsunami. We are at a lot of conferences and things like that. So although we have upped our kind of technology game during COVID because we didn't have a lot of choice, we definitely are boots on the ground out in the communities a lot.
No, just add to that, we have a whole bunch of publications and materials that, yeah, if you are interested in that sort of thing, again, I recommend talking to your local emergency management first. So you can reach out to them through our mil.wa.gov/alerts page. We have their connected information. But if they don't have people available to support, we have our email as well, public education, whether you're looking for materials or potentially us to come out and talk to people. But try to go local first, because they'll have the details on your local area and what your hazards are first. It's a possibility.
But yeah, we have a lot of physical materials. We, from time to time, not always, so I can't promise, but from time to time, we have NOAA weather radios that we usually either are giving out at events or distribute to the local jurisdictions to hand out, and we provide assistance if you're having trouble programming those. But yeah, we try to help out and get out in the communities as much as we can, especially now that we are able to more. We like meeting people.
That's it from my end.
Did Sir Washington have anything to say about CERT, or would you like to add anything? Thanks again for having us.
Yes, if people are interested in the community emergency response team, you can go ahead and notify me here at Sir Washington, or just type in Sir Washington and look for my name on the staff, and I will return your call and give you training if that's what you choose to do. Thank you.
Awesome. Well, thank you everyone who's still with us. I know we ran over and it's a long webinar anyway, but we really appreciate the chance to talk to all of you and give you this information. Again, if you have any questions or concerns, or if you're having trouble finding something that we talked about online, please reach out to public.education@mil.wa.gov. Our team is always happy to help answer questions, find new resources, send you resources, come talk to groups, do whatever it is that you need. So thank you so much. And looks like the day's turning out real nice. So have a good rest of your day and have a great weekend, everyone.
Thank you, everyone.